Okay, so this is book 2, question 31. So here we're told that Richard mows 1/3 of his yard in half an hour. So that's a ratio right there, a comparison between two amounts. Now, the first number, 1/3, I'm going to write as a numerator for a ratio, because this is a ratio. So his yard, I'm going to use y, has 1/3 of it mowed, and the time in hours takes him half an hour. So don't be worried that this is a fraction over a fraction as a ratio. That's perfectly fine. Now, the question is really asking us how much of his yard would he mow if it took him 1 hour. So therefore we're told the denominator for the second ratio. So the hour, we're imagining, is 1, and we're trying to find x. So here there's a couple of ways to do it. The first method that I'm seeing, because we can spot how 1/2 turns into 1, well, it doubles. So therefore we times by 2. So on the top, what we can do is just times this 1/3 by 2. So when we do 1/3 times by 2, we get 2/3. And so that's our answer. In 1 hour, he can mow 2/3 of his yard. And 2/3 is there, it's C. Now the other method to do this is, once we have 1/3 compared with 1/2, so this is the yard to the hours, and remember we had equals x over 1, well, x over 1 is really just x, and so to find out x, what we can just do is 1/3 divided by 1/2. And in this case, let's not forget that when we are dividing fractions, you keep the first fraction, you change the sign, so the division sign turns into multiplication, and you flip the second fraction, you find the reciprocal, which is 2/1. And in this case it comes out the same thing, 2/3. 1 times 2 is 2, 3 times 1 is 3. Okay, so that was number 31. Okay, so question 32. The probability of an event is 1. Which word best describes the probability? Well, this question really goes back to our knowledge of the probability line. So often probabilities are written in percents. You can have 0%, you can have 25%, 50% right in the middle, then 75%, and 100% is the max. Now obviously you can have increments that are much smaller as well. Now this is showing probability as a percent, but we could also show it as a decimal. It would be 0, 0.25, 0.5, 0.75, and 1. And oops, that was as a decimal, but we can also do it as a fraction. 0, 1/4, 1/2, 3/4, and 1. Now the key thing here is that this one does not say, it is not 1%. If it was 1%, then it would live right here. It would live very, very close to 0. This is 1%. Instead, it just says 1 on its own. So therefore, it is talking about the probability as a fraction or a decimal, which is the same as 100%. Now, something that is 100% likely to happen means it's definite, and that word isn't there, but another word for definite is certain. And so A is our answer for number 32. Okay, this is question number 33. And 33, we are told the graph below shows a proportional relationship. So as soon as we hear this, we've got to think of the proportion equation, which is y equals kx. And it says, what is the constant of proportionality? And so really we're looking for our k. Now, you know, just a little bit of background is that even if it didn't tell us this was proportional relationship, we've got a straight line, and it goes through the origin. So it goes through 0, 0. And so these two criteria tell us that it is indeed a proportional relationship. So a few methods to do this. The first method is to know y equals kx and then just choose a point. So I'm going to choose this point right here, which is 3, 21. Now this means that when x is 3, y is 21. So what we can do is we can substitute the 3, which is our x, and plug it in. We can substitute our y as 21, and so we can rewrite this equation as 21 equals k times 3. So if we divide this by 3, they cancel. Got to do the same to the other side. So k equals 7. And so in this case, C is our answer. Now, another method to do this is knowing that the k is the constant of proportionality, it's the slope, it's the rate of change, and it's the unit rate. So if we know that k is the unit rate in this equation, and so the unit rate is the same as this constant of proportionality, there's another little trick that we can do, which is to look at the point 1, r. Now this basically tells us that when we look at an x value of 1 right here and we go up to the line, it will tell us our value of y, which in this coordinate pair here it's called r, but this will tell us our unit rate. Now here it's actually very difficult to read off between 6 and 12 where this is falling, because it's very close to 6, but that gives us an idea that it's somewhere just slightly higher than 6. And if we look at each of these, the only number that is slightly higher than 6 is C. So this is another way to tell. As long as we remember that the constant of proportionality is the same as the unit rate, and that we have this 1, r to help us find that unit rate, then that's another method for solving this. And finally, here's another way. The constant of proportionality is also the slope. And so for the slope of the line, we can look at 2 points. So we could look at we could look at these 2 points, 3, 21, and we can look at 5, 35. And to find out the slope here, we look at delta y, which just means change in y, over delta x. So our change in y is basically goes from 21 all the way up to 35. So this 21 turns into 35 by adding 14. So the delta y is 14. Now the 3 turns into the 5 by adding 2. So therefore the 3 goes to the 5 by adding 2, so we would put 2 on the bottom. In this case, 14 divided by 2 also gives us 7. So those are 3 methods. Probably the first method is the easiest and the most straightforward, as long as we remember that the graph shows a proportional relationship and that this applies. Okay, so that's question number 33. Okay, so 34. Okay, in this question we're told that Montel sold 13 popcorn buckets, and he also sold 13 fruit baskets for a fundraiser. The fruit baskets cost $20.75 each. So I'm just making these notes, and Montel raised a total raised of $468. Now this amount that he raised is based on 13 fruit baskets at $20.75 and 13 popcorn buckets at X. We don't know how much each of these cost, and wouldn't you know it, the question is asking us how much did each popcorn bucket cost. So it's asking us to find X now that we've set it up in this way. So a couple of ways to solve this. First one, using our equation knowledge and logic, is we're going to say, well, you know what, he sold 13 fruit baskets right here, 13 fruit baskets, and each of them cost $20.75. So we're going to multiply these, $20.75. That's going to tell us how much he raised just by selling those fruit baskets. And then, connected with that, we need to add how much he raised by selling the popcorn buckets. Now, we know there's 13 sales that he made, and each of them cost X. We put our X here, meaning the price for each. And when we sum these, it would come to $468. So if we start this off by doing 13 times by 20.75, that gives us, over here it gives us 269.75. And that's going to be added with 13x, whatever x is, and that equals 468. So now the next step is to subtract the 269.75 from both sides. Notice that I'm lining this up, so there is a point there and there's the invisible zeros over here. Now what this gets us over here is they cancel and we get 13x on its own, and so 13x equals the 468 minus the 269.75. So that gives us an answer so far of 198.25. So to get x on its own, we're going to divide by 13, do the same to both, and so we get our answer of x equals, now the 198.25 divided by 13, that gives us $15.25, $15.25. So that's the first method to solve it. So as long as we very carefully construct this equation, then we can solve it in this manner. Now another way that we could solve this is to grab the orange, is to use the answers to help us. So we know that he sells 13 popcorn buckets and he also sells 13 fruit baskets. So to find the total from the fruit baskets, we would do 13 times by, and he sold them each for $20.75. To find the total for the popcorn buckets, we do have 13, but we're not sure what to times it by. So what we can do is we can go through these and try them. We can try to put in there 36. We can try to put in there 33.75, which is right here. We can try to put in there 22.55. And then finally, which would be the right answer, we can try to put in there 15.25. So by trying each of these, and it might take all four of them if we did them in order, what we could then do is try and figure out if when we get our sum for here, whatever it is, and we get our sum for here, and we add these two together, we should get a total of $468. And so if we're stuck and we can't quite get this equation together, with multiple choice, often you can use these answers in a smart way to try and narrow it down. And that's exactly what we did here. And we would find that 15.25 is the only one that works when you multiply by 13 and then add the 13 times 20.75. That's the only answer that gives you a grand total of 468. And so D would be your answer in this case too. Okay, number 35. Okay, in this question we're told she bought 3 pairs of shoes and it cost 38 each. And we're told there's a rate of 8% and it wants to know how much did she pay. So first of all, $38 per pair. She bought 3 of them. So before tax, the amount is, that's a 4, 2, 9, 11. The amount is $114. Now remember, this is before tax. If you got carried away right now, B is looking very tempting, but we haven't added on the 8%. So what we've got to do is we've got to do the 114, and then here we've got to add the 8%. Now it's very tempting just to think, you know what, just add 8 to it. But that's not going to give us the right answer. To find out what 8% of 114 is, we can do 114 times by 0.08. And if we did this work, 114 times by 0.08, that gives us an answer of 912. So we could then put the 9.12 here and we could add them up. That would give us a 1 and a 2. Remember, this is like 0.00 with this top number. This would give us point and then a 3, carry the 1, 2. So this would be our answer, which is A. Now, another way to do this is to think of the box method. So if we are trying to find out what 8% is, 100 would always go here. In the percent box we would do 8. In the part box we would do X, because that's what we're trying to find, how much is it X. And in the whole we've got 114. So this is actually giving us the position of our two ratios for the proportion. So we've got X over 114 equals 8 over 100. So here if we cross multiply by doing the 114 times the 8 and then the 100 times this, we get 100x equals, and we would do 114 times by 8, which equals 912. When we divide by 100 and divide by 100, we're going to get x on its own, and x would equal 9.12. Remember, when we're dividing by 100, all we're doing really is moving a point 2 places back in there. Now at this point we must remember that this is only the 8% tax, and that we've got to add it back on to the 114, which is what we did up here. Now I'm just going to show you one other method. I'm going to put this over here. Now if we know that the total before tax is 114 and we know that the tax is 8%, what we can do is consider this problem really asking us to find what is 108% of 114. And so we could do that by doing 1.08 times 114, and that would give us our answer of 123.12. Notice here it goes straight to our final answer. We don't need to add this 8% tax back as we would have to do in the previous two methods of solving. So this is possibly one of the fastest ways to do this for number 35. Okay, number 36. Okay, so number 36 is saying that their home is 2550, let's write it, 2550 feet squared of living space. A contractor is building an addition to their home, so they're extending their home, and it's going to increase the square footage by 8%. So it's going to increase by 8%. What would be the square footage of their home with the addition? So really we need to add on this 8%. Now I'm noticing that this answer here is going to possibly trick a few people. Some people are going to think that this is 2550 plus 8, which would give you this answer, but it's not. It's not plus 8, it's plus 8%. So we need to find the value of this 8%. So just like the last question, we could do 2550 times by 0.08, and so the square foot value of this 8% is really 2550 times by 0.08, which equals 204 feet squared. So when we add on the 204 feet squared, we get 4572 feet squared. So our answer is going to be D. And just like in the previous question, there was a nice kind of maybe faster way to solve this. if we're looking to add on 8%, we're really looking for 108% of 2550. And so in this case, we're looking to do 1.08 times by 2550. And so if I do that right now, 1.08 times by 2550, then I get my answer of directly 2754, which is answer D. And so this possibly, as mentioned last time, is a faster way to do it, and also it's very useful if we can see that really we're looking for 108%. Okay, that was 36. Okay, question number 37. Okay, which statement about a data set provides the most information? So everything here is going to provide information, but it wants to know which statement about a data set provides the most information about the variability. Now, straight away, when we're thinking variability, we're thinking fluctuation, we're thinking change, we're thinking spread, we're thinking range, we're thinking all of these things. We're thinking the distance between the data, we're thinking of the deviation, we're thinking all of these things that are connected with variability. Notice we're not thinking about the average, because the averages are really the measures of center. So let's take a look in here. Okay, so A, the mean of the data is 28. Well, again, this is really a measure of center, and this is an average. So it's not A, that's telling us more about the middle or the center. The median of the data is 30. Well, again, it's useful. It is telling us some information, but it's not telling us a lot about the variability. The range of the data set is 18. Well, range is definitely something to do with variability. So it's looking like C. And D, the maximum of the data set is 40. Well, you know, if you've got a lot of different data points going from biggest to smallest, your maximum is definitely useful, but unless you have the minimum, it's not easy, or in fact it's not even possible for you to talk about the spread of the data or the range. So you need more than just one number to talk about the variability. And so the range is one number, but it's telling you about the spread from the biggest to the smallest. So the range, C, is our answer for 37. Okay, number 38. Okay, so in 38 we're given a dot plot, which here it's saying a line plot, and below it shows the number of minutes it took Greg to get to work each morning for the last 27 days. So if we counted them, 1, 2, 3, 4, there's going to be 27 X's there. There's going to be 27 of them. And it says, which statement best describes the data? Okay, so as we look through it, the median amount of time it took him was 58 minutes. Well, I'm looking here, there's nothing at 58, but the median could still be there. So one method to find the median is to list them. So if we would be listing all of these, well, we've got everything in order: 52, 52, 52, and then 53, and then 54, 54. So as you notice, I'm writing out the full list. Now, this could take me a while. So in this case, there's a faster way to find the median of this set. And because there's 27 data points, if we find the middle position of this, it would actually be the 14th, because 13 plus 13 splits 26 data points, and so the 14th data point is the median. And so how that helps us is this dot plot is already in order from smallest to largest, so we can just count through them: first, second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, and so I'm just going to change the color for the 14th. 14th, and so this is your median. And if you kept counting here, there would be 13 data points on the other side. And so if our median is here, it means the median equals 59, and so it's not A. Okay, for B, the greatest amount of time it took him to get to work was 60 minutes. Well, that's not true, because here I'm seeing times that are bigger. I'm seeing 62, so it can't be B. C, there is a peak in the time it took him to get to work at 59 minutes. Well, this is a peak, and it's also the mode. And so the mode equals 59, and so it's looking like C. Let's just check though. It says the mean amount of the mean amount of time it took him to get to work was 56 minutes. Well, looking at it, there's a little trick for us to know that that's not true. If we wanted to solve the whole thing, we would need to find the sum of all of the data. So we would need to do 52 plus 52 plus 52 plus 53, and we would keep going, and then we would divide this by 27, and that would tell us what the mean is. Now in this case, that's going to take me a long time, but looking at it, if the mean was around 56, now that's just as assuming that this is correct, then that would have to be the middle number based on the sum divided by the number. And as I'm looking at this, I'm going to change the color to green, and if you look at it, there are so many numbers, so many more numbers that are higher than 56, that are greater than 56, and the shape, the clustering of this data is all pretty close, that because there's so many more that are higher and everything is pretty close together, to me it doesn't look like this is the mean. It looks like the mean would be a lot higher. The mean would be more than 58 in this case, looking at the spread of this data. So I'm not convinced with D, and because C seemed to make a lot of sense, I'm going to go with C here. So that was number 38. Okay, so question 39 is about proportional relationships. So we're told that a school band held a fundraiser by selling books and also magazines. The diagram shows the number of books that Donna and Gemma each sold are proportional to the number of magazines that they each sold. And so we've got a key. So the first thing to make sure is that each picture is really only one. Some keys might say, well, picture of a book equals 5 books, picture of a magazine equals 2 magazines, but here it's nice, they each mean one for one. So I'm going to make a little table for Donna. I can do, I've got magazines and books, so I'm just going to fill in how many magazines and how many books. Magazines are 1, 2, 3, 4, 5, 6, 7, 8. She sold 8 magazines, and books, I'm seeing we've got 1, 2, 3, 4, 5 by 1, 2, 3, 4, and then 5, but we've got to subtract this one. So we could use area. 5 by 5 gives us 25, minus this one is 24. That's a quick way to count them all. And Gemma, we can do G over here. Gemma's magazine and books. She's got 1, 2, 3, 12 magazines. Now her books, 6 by 6 is 36. Now it says the diagram shows that the number of books Donna and Gemma each sold are proportional. The books are proportional with the magazines. And so with any proportional relationship, we could write it as y equals kx. Now here we're given different constant of proportionalities. Now remember, that's the k. We're given different k's. We're given a third, 1 2/3, 3, and 6. And also sometimes that's changing the position of the word books and magazines as well. So let's take a look. If we're wanting magazines per book, we're trying to really think about which way the M and the B should be. So let's just say that this is our book, the X, and the M is in magazines, which would be a Y. So let's try and think of this in this way right here. Now when the books are 36, the magazines are 12 here. So therefore we've got to think what number times the 36 would give us a 12. And so sometimes we might be able to see it that it's 1/3, or we could solve by just dividing by the 36 and doing divide by 36. So in this case K equals 12 over 36, which actually simplifies to 1/3. Now that should be the same with the other one as well, and if we stick with M equals K times B, our M is 8, our B is 24, and then we've got a K. So if we divide both sides by 24, divide by 24, then in this case K equals 8 over 24, which is the same as 1/3. So it's 1/3 magazine per book, which kind of makes sense, because if it looks a little tempting for C to be our answer, 3 magazines per book, but if we just think about it, they are each selling fewer magazines per book. Okay, so it's worth noting that if we had our M and our B a different way around here, we might have got we might have ended up with a K of 3 instead of 1/3. Now if that was the case, a K of 3 would basically be telling us that they do 3 magazines, they do 3 books for 1 magazine. So it's very important that after we get our K, whatever it is, that we really think about, is it magazines to books or books to magazines? And so in this case, even just by looking at it with fewer magazines happening for every book that they sell, we know that A is the most likely and is the correct answer here, just by looking at it. So A is your answer for 39. Okay, question number 40. Okay, so Luann made a photocopy of a drawing of a rectangle, the original drawing. So again, as soon as you see this stuff, rectangle, just draw out the stuff. It's much easier dealing with pictures. The original drawing was 4.5 inches wide, 4.5 inches wide, and 6 inches long. This was the original. Now the copy, so we put copy, the copy was 6.75 inches wide and 9 inches long. What was the scale factor for Luann's copy? So again, this is a y equals mx, sorry, this is a y equals kx type situation. And so she's obviously enlarging the picture. And so what we've got to do is think of our corresponding sides. So the 4.5 turns into 7.5, and the 6 turns into 9. And so sometimes we can see what it multiplies by, and that's our scale factor. If we could think of what exactly is it that we multiply 6 by to get 9. However, if we can't see it, all that we have to do is plug in. So our output here is the 9. So we could do 9 equals k, which is the scale factor, or the constant of proportionality, times by 6. And so in order to get k on its own, we would divide both sides by 6, and that would give us k equals 9 over 6. And so k equals, when we simplify this and everything, equals 1.5, 1.5. So this would still be the same if we use the other two numbers as well. We could have done the 6.75 equals k times 4.5. Would have given us exactly the same answer. A is our answer in this question. Okay, number 41. Shannon flipped a coin 50 times and it came up heads 27 times. What is the relative frequency of tails? Now, we know that it should come up half the time, but the relative frequency means how often did it actually come up tails. So in this case, it came up tails 50 times minus 27 times, which were heads. That gives us 23 times that it came up tails. And so if it came up 23 times tails, it came up 23 out of the 50 times. So 23 times tails out of the total. And so if we want to convert this to a percent, we're trying to turn this into a percent, well, I'm noticing it would be pretty easy to get this over 100 right now. So to get this over 100, we are just going to times the denominator by 2 and times the numerator by 2. So timesing the numerator by 2, we end up with 46 over 100, which equals 46%. And so the relative frequency of tails is 46%. Okay, 42. Which expression is equivalent to 14 minus 9? Well, we could just look and try and compare and figure it out, or we could just work everything out. So 14 minus 9 gives us 5. If we're on negative 14, so number line can also help us. 0, let's say we're on negative 14. If we're adding 9 here, we're not going to go past 0, so this is still going to be negative, and it's going to be negative 5 is our answer here. Over here, if we're at negative 9, so I'm going to draw another number line. If we're at negative 9 and we're minusing 14, we're going to be more negative. We're actually going to be at negative 23, so that doesn't equal 5. Okay, C, the third option. If we're at 9 and we're subtracting 14, well, I'm going to keep going past 0 when I'm subtracting 14. And so 9 minus 14 is going to give me negative 5. And so I know it has to be D, but let's just do the work right here. 14 plus negative 9. Well, when you're adding a negative, you are subtracting. So this equals 14 minus 9, which, in fact, let me just circle these in a different color. It's exactly the same as what we've got up here. These two are exactly the same, so we don't even need to work it out at this point. They are equivalent. They're the same. If we did work it out, it would equal 5. For number 42, D is our answer. Okay, 43. In 43, we're told that the graph shows the relationship between the attendance at a school basketball game and the amount of money collected from ticket sales. So a few things that I'm noticing: it goes through 0. This is before I even read the question below. It goes through 0, 0, which is the origin, and also it's a straight line, which means these two things together tell us it's a proportional relationship, and so I know that y equals kx. Let's see if any of this is useful. What does the point 0, 0 represent? Okay, so let's see. If no one attends a game, no money will be collected. Well, that seems to make sense. 0, 0, the attendance is 0, and also the amount collected is 0, so that makes sense. A is the answer. Okay, we could go through the other options. No one attended the game. Well, this graph is showing the relationship between the attendance. It's not telling you what actually happened. It's basically this ticket sale graph is showing that as the attendance increases, so does the amount collected, and it increases at the same rate. So it's not about nobody attending the game, it's about showing the relationship between these two numbers. Okay, so see, this is the unit rate of the money that will be collected for each person attending the game. Well, that's not going to be true, and also if it is the rate of the amount of money each person collected for each person, it means that they are not making anything from each person, which doesn't make any sense, so it's not going to be C. D, this is the unit rate of people attending the game per dollar collected for tickets. That's not really making much sense either. Our answer is A. If no one attends a game, no money will be collected. And that makes sense from looking at the graph, and it makes perfect common sense as well. Nobody goes, how are they gonna make any money from tickets? They're not gonna make anything, right? Okay, so that was 43. Okay, so 44. The ages of male and female homeroom teachers at Lincoln Middle School are listed in the table below. So we got male, we got female. And it looks like they're not really arranged in any particular order. It's just a mixture of 9 numbers. Okay, which statement best describes the variability of the two sets of ages? Okay, so the interquartile range of the ages of the female teachers is 4 more than the male teachers. Okay, so it looks like everything here is about interquartile range. So what we've got to do is we need to show a box and whiskers plot. So to show a box and whiskers, we need the minimum and the maximum numbers. We also need the median, which is in fact our second quartile, and then we also need the first quartile and the third quartile. So I'm just setting this up right now. Not very neat. Hopefully we would have a grid or something to help us. So we still need to find this data. Now let's just put these in order. So my smallest number for males looks like 25. So I've got 25, and then 29, 31, 36, 37, 42, 45, 57, and 58. Okay, so my middle number here, which is the median, be 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 of them, so it's going to be the 5th number. 1, 2, 3, 4, 5. That gives us 4 on each side. So our quartile 2 for male is 37. And now, as I'm trying to find the first quartile and the third quartile, remember, interquartile range equals the third quartile minus the first quartile. So to find out what these two numbers are, quartile 1 and quartile 3, we need to look at the remaining numbers on each side of the median and basically take the median of those. So over here I've got 29, 25, 29, 31 and 36. So I could think of this as cancel, cancel, and then I've got 2 left. And so the middle of 29 and 31 is 30. So 30 is my quartile 1. If I do the same over here, cancel, cancel, and now I've got between these two numbers. To find the middle, I might want to just look at the mean. So 45 plus 57 all divided by 2. Well, 45 plus 57 is going to give me 40 and 57, 97, 102, 102. And then I'm going to divide that by 2, so that's going to give me an answer of 51. So here, quartile 3 is 51. So the interquartile quartile range for the males is 51 minus 30, which is 21. Now I've got to do the whole thing again for females. So I'm going to have to write out my list. 23, 29, then I've got 33, 37, 41, 46, 47, 51, and 53. Now the fifth one is going to be the 1, 2, 3, 4, 5 is going to be the median, and so I could plot out this whole thing. And you know, up here I didn't do it, but our minimum number would have been 25 and our maximum is 58 if we need to show everything. Our median here, which is also the second quartile, is 41. Our minimum is 23, our maximum is 53. So now the key thing is finding out what the first quartile is and what the third quartile is. Now remember, our interquartile range is Q3 minus Q1. Okay, so let's find the median of each side. So I've got between these two. So 29 plus 33 all over 2. Well, that's going to give me 59, 62 all over 2, which equals 31. So 31 is the value at Q1. Then over here, cancel, cancel, and now it's between these two. So here my number is going to be 47 plus 51 all over 2, which is going to equal 98 over 2, which is going to equal 49. So let's put that there. So we're almost done with all these calculations. Quartile 3 is 49 minus quartile 1, which is 31, which is going to give us an IQR, an interquartile range of 18. So this is interquartile range of females. So really what we're doing is we are comparing this right here with this right here at the top. So let's see, A, the interquartile range of the ages of female teachers is 4 more than that of male. Well, let's put this together so it's nice and clear for male and female. And we are looking at the interquartile range. Well, the male interquartile range was 21, the female was 18. So the male is actually 3 more than the female. So A is not the correct answer. B, the interquartile range of the ages of the male teachers is 4 more than that for female. Well, that's not true. Okay, C, the interquartile range of the female is 3 more than the male. Females aren't 3 more than male, so C is incorrect. So it's got to be D, but let's read it through. The interquartile range of the ages of the male teachers is 3 years more than that of the female. That's true. Male here is 3 more than the female, so D is our correct answer. Okay, number 45. Okay, so Patrick read 20 pages of his book in 4 hours. 20 pages, 4 hours. And remember, this is Patrick. Okay, Todd read 25 pages in 5 hours. So each of these are rates. Each of these are rates. Did both boys read at the same rate? So in order to find this out, what we really want to do is find the unit rate. And so the unit rates of each. Patrick, the unit rates is how many pages per 1 hour. So in this case we're going to do 20 divided by 4, which gives us 5 pages per hour. And then Todd's unit rate is 25 pages in 5, so the unit rate is going to be 5 pages per hour. So they are exactly the same. So the unit rates are the same, so they did read at the same rate. So I know it's not going to be A, because it says no, that they didn't read at the same rate. It's not going to be B, because that also disagrees with the question, did they read at the same rate? So it's got to be one of these two. Now, we just calculated the unit rates by doing 20 divided by 4, which is here, and we also did 25 divided by 5, and we found that the answers to this question both equaled the same thing, 5. The unit rate was 5 pages per hour. And so because they equaled each other, that's the reason why they both read at the same rate. So our answer is D for number 45. Okay, number 46. Here we're told that she's tossing a fair coin, so 50-50 heads and tails. It says that she tosses the coin 10 times and it lands on heads. Lands on heads 8 times, which means that it must have landed on tails twice. And the total, we're told, was 10. That's how we knew it was tails twice. It says, if Maria tosses the coin an 11th time, what is the probability that it will land on heads? Now this question really is trying to trick you. The coin itself might have a head, but it doesn't have a memory. It does not have a memory. So therefore, after all of this stuff has happened, and it doesn't matter if we got a whole bunch of heads, the next time, the 11th time, the probability of getting a head is, back to the theoretical, is 1/2. And so B is your answer for number 46. Okay, number 47 says Chris used 45 feet of fencing to enclose his circular garden. So 45 feet all the way around, 45 feet. It says, what is the approximate radius of the garden? Well, first things first, we've got to think, what is it that we know? Well, we know that we've just been given the circumference. We've got to try and now see this picture as circumference. So we know that C equals 45 feet. We also know the formula for circumference is 2 pi r. So in this case, we're asked for what's the approximate radius. And so what we're going to do is we're going to plug in the 45. So we've got 45 equals 2 times pi times r. Okay, so now to get r on its own, we're going to divide by 2 pi. Divide by 2 pi on both sides. Now the reason we do this is because we want to get the r on its own. And so that's what happens over here. Now on our calculators, we can do this right now, is we need to divide 45 by 2 pi. So 45 divided by 2 pi is, let's just press the pi button, equals 7.1619, and it goes on. Now I'm saying all of my answers over here are to 2 decimal places, so I'm going to put mine to 2 decimal places as well, to the hundredths. So I've got r equals 7.16 feet. So that's the way that we do it. Now if we were stuck with how to get started with this, what we could do is, as long as we recognize that the 45 was the circumference, we could go through each of these calculating 2 pi r. So C equals 2 pi r. So here we could do 2 times pi times 51.27, and we could find out if that equaled 45. And we could do 2 times pi times 14.32, and we could see if that equaled 45. So whichever one of these, and it would be C, 2 times pi times 7.16. This is going to be very, very, very close to 45, and it's the only answer that is. So for number 47, C is your answer. Okay, so 48, this is a question about sampling. A store owner is considering extending the hours of the store that the store is open each day. He conducts a survey to determine if longer hours would be worth the expense. So, survey. Which survey method would likely produce the most representative sample? So whenever we're thinking about a survey and sampling, we're always thinking about valid data, a valid sample, and we're trying to get rid of any bias. Because if there is a lot of bias in the data, it's going to mean that it's an invalid sample or an invalid survey. So this is very important to make sure that in the real world people don't spend a lot of money asking questions to a sample of people who aren't representative of the population. So let's go back to the question, which survey would likely produce the most representative sample? So remember, it's to do with whether a store owner should extend his day, extend the hours that the store is open. So A says choose 20 random customers from the neighborhood. So that's pretty good, random. Now, it's only 20. 20 isn't a lot, but I'm saying that 20 is in here for everything, but wow, it does say would produce the most representative. So I think right from the start, I think he's going to ask more than 20 people, but as each one is only saying 20 people, I guess we got to go with that. So that seems pretty good. Random customers from the neighborhood. It is only going to be people from the neighborhood who are going to his store, probably. Now, his customers, he's going to ask random customers. This is only customers. Maybe there's some new customers who aren't his customers now who would come if it was a longer day. But let's just keep that in mind. That seems like it's a possible. Choose 20 full-time employees from the store. Well, there's definitely going to be bias there because they work for him. So they're probably going to say, sure, extend the day and give me the overtime. So I don't like B. There is a lot of bias in there straight away. C, choose 20 customers who spend the most money in a week. Okay, so he's conducting a survey to determine if longer hours would be worth the expense. Okay, so the 20 customers who spend the most money are definitely important, but that doesn't necessarily mean that they're going to come back later, and it means that it's not really representative because he's probably got a lot of customers who don't spend a lot of money there as well. So I don't really like C. So far A is my top choice because it's just talking about customers in the neighborhood. And D, choose the first 20 customers that come in the morning. Well, if he's trying to find out about extending the day, later hours, then the early birds, the people who are coming first in the store, might not really be interested in extending the day because they're already coming early. So he's going to miss out on people who come in the afternoon and later on in the day as well. So I don't really like D. So generally speaking, I don't really like any answer here because I think his sample size is too small, and also he's only just focusing on customers. But maybe he could do a survey during those later hours when he's currently closed. He could survey people outside his store and just say, hey, if my store was open right now, would you go and shop there? But regardless, A is the best choice here because it reduces the bias, even though there is still some bias in there. Okay, question number 49. 49 is saying that they jogged 2/3 of a mile in 1/12 of an hour. So I'm just setting this up straight away. We're given a comparison of two amounts, so write the ratio as a fraction because it's probably going to ask you to solve a proportion. So what was his speed in miles per hour. So speed equals distance over time, which kind of makes sense because miles per hour is a unit rate. And even just by looking at miles per hour, the units, we got miles per hour. Miles a distance slash 1 hour. So in order to do this, what we need to do is we could just divide these from the start. 2/3 divided by 1/12. That will give you the answer. Or we can think of it as a proportion, X number of miles in 1 hour. And then we could cross multiply and do all that other good stuff. Now, the method that I'm going to use right now is because I know that X divided by 1 is X, then when I bring this down, this is saying 2/3 divided by 1/12. So as long as we're remembering the rules to divide fractions, that's going to mean that X equals 2/3. Now divided by 1/12 is the same as multiplying by the reciprocal. So you keep the first, you change the sign, and you flip the second fraction. And that's exactly what we've done. So 2 times 12 is 24, 3 times 1 is 3, 24 divided by 3 is 8, so that's 8 miles per hour. And so D is our answer for number 49. Okay, number 50. Okay, so in 50, we know the class is going to a concert to raise money for, is organizing a concert to raise money for charity. The graph shows a relationship between the number of tickets sold and the money collected. And that kind of makes sense. If they sell 0, they're not going to collect any money. It's going to be 0 as well. So which equation shows a relationship that is represented by the graph? So we've got the money, which is like the Y on the Y-axis, and we've got the number of tickets sold, which is on the X. So as this is a straight line that passes through 0, we know it is a proportional relationship, so we know Y equals KX. Now instead of the Y and the X, we've got the M and the N. So this is our proportionality equation. So there's a few ways to do this. One is I'm going to look for a point right here that is on the grid. So this looks like a nice point where I can read it. So I know that when N is 5, the M is 100. And so now I can take this information, and we could have chosen this point that looks like a good one, or this one looks like a good one. These look like they can easily be read. Let's just remember it's 5, 100, which is exactly what I've got in this table. Now I'm going to take these values and I'm going to substitute them. So M was 100 when N was 5. So in order to find K here, I'm going to do the same thing to both sides. I'm going to divide by that 5, so they cancel. That gives me my K. I've almost got that equation right now. So I'm going to divide the other side by 5. 100 divided by 5 is 20, so gotcha, got the K. So our equation now becomes M equals 20 N. So this is our proportionality equation for this graph. Thank God it's there, it's A. A is our answer for number 50. Number 51. Now in this question we have a term and another term and another term and another. So we've got 4 terms in there. Now 2 terms in this parentheses are called a binomial. So that's good to know. And this is another binomial, which just means bi means 2, binomial means 2 terms together. Now when I'm looking at this, I'm going to circle them in different colors. I've got my y's, so I've got negative 4y here, and then I've got 12.7y here, but we must remember that that is minus. And then my regular old numbers without the variable, I've got 20.1, and then I've got 9.3. So we're going to group these we're going to combine these like terms, but first of all I'm going to write out this problem again, but I'm going to do something with this negative because both of these are wrapped around parentheses. So I'm going to remove the parentheses from the first, so I've got negative 4.8 y plus 20.1. Now, because this says minus, that's going to have an effect on everything inside the parentheses. Now, it was just a plain old 12.7y, which meant that it was a positive, but because I'm subtracting what's in the parentheses, it's going to become minus 12.7y. And over here, although it was plus 9.3, because it's minus whatever's in there, I'm going to change that as well. So the minus sign basically changed the sign in front of each of these. So now I'm going to group them. I'm going to use my orange again, so I'm going to include the minus, the negative, with the 4.8y. I'm going to include this over here as well. And then let's combine these right now. So I know I've got minus this and I'm minusing more, so my answer is still going to be negative. So what I'm going to do is I'm actually going to add the absolute values of these. I'm going to add the 12.7 with the 4.8. So that gives me 15, carry the 1, gives me 7, so that gives me 17.5. Now, it was negative already, and I'm subtracting more, so it's going to be negative 17.5y. Must remember that y, because really each of these are y's. And then I'm going to plus, now I've got this 20.1, and then I'm going to include with the term the negative. Got 20.1 minus 9.3, so let's do that math over here. 20.1 minus 9.3, so in this case I'm going to have to carry over and borrow, so it becomes a 1, that becomes a 1. And now in this case I'm going to even cancel the 10, turn it into a 9, and then pass the 1. So 11 minus 3 gives me 8, 9 minus 9 gives me 0. Make sure to leave that point, and the 1 stays. So now let's go back to the blue pen. That's a positive 10.8, so I'm going to add 10.8. Now keep in mind there's nothing else I can do here because this term has a y, this term doesn't, so that's the best that I can get. I can't combine anything else right now. And so I'm looking for my answer. It almost looks like D, but this doesn't have a negative there, so it's not D. It's not C, it's not B. Looks like it's exactly the same as what's in A. So A is our answer for number 51. Okay, 52. And 52, it says which graph shows a proportional relationship. So we've done this a few times right now. If it's a straight line and it goes through 0, 0, 0, I should say, the origin, then it's a proportional. Well, that's not a straight line. It has a bend in the middle, so it's not A. Okay, this one also has a bend in the middle, so it's not C. So even though it's missed off, this one was B and this one was D. Now D also has a bend in the middle, so it's not D. This one is a straight line and it goes through the origin, so it is B. 52 is B. Okay, 53. Monique drew a square and inscribed a circle on a sheet of paper as shown below. So inscribe means you just draw the shape inside, so it just touches the other shape on the inside. It says Monique randomly drops a pen point down to leave a mark on the drawing. What is the probability expressed as a percent that the pen mark will land inside the square but outside the circle? So it wants to know the probability that the pen is going to land inside one of these 4 sections. Now, okay, so this, although it's asking us for probability, this is really an area question as well. And we've got different areas here. We've got the circle, we got the circle area, which A equals pi r squared, which in this case our radius is from the middle to the edge. Now because the outside we know is 16, it means that the radius here must be 8 centimeters. So this must equal pi times r squared, 8 squared. So this equals 64 times pi. We're told to use 3.14 for pi. So when I do 3.14 times by 64, that gives me an answer of 200.96. And our units are centimeters squared. Now, we just found out the area of the circle. That, you know, we're not even halfway there towards this probability right now, but let's find out the area of the square, which is 16 centimeters by 16 centimeters. So if we're looking for the area of the entire square, A equals LW, which equals 16 times 16, which equals 256 centimeters squared. So the reason why we did this is because if we're looking for the probability of it landing in, now I'm just calling it orange, if we're looking for the probability of it landing in one of these 4 orange sections, then we need to take the area of the square and subtract the area of the circle, and that will give us the areas of each of these 4 sections. And we need to know the area of each of these 4 sections, because then we can divide this area, we can put that over the total area of the square, of the whole piece of paper, and that ratio, let's get started with that. We've already got the area of the square, which is 256. It's going to do 256, and we're going to subtract 200.96. And so remember, that's going to give us the area of all of these little squares. So 256, sorry, these little, they're not squares, these little almost triangular pieces, but not quite, but the corners. So 256 divided by 200.96 gives us an answer of 55.04. Remember, this is area, so it's this. Now, the probability of landing inside the square but outside the circle is basically the area of these 4 pieces all over the area of the entire thing. So, you know, this goes back to basic probability, where it's the successful outcomes over total outcomes. Well, total outcomes is comprised of the area of the square, and successful outcomes is comprised of the areas of the successful pieces, the pieces that win the game in this case. And also it wants our answer as a percent, so we would have to multiply this by 100 too. So let's get to work. We've got the area of those 4 corners is 55.04. The area of the sheet of paper is 256, and then times by 100. So I'm going to do this in one shot right now. I'm going to take the 55.04, divide it by 256, and then times by 100. I get an answer of 21.5%, and so D is our answer. And they didn't really need the trailing 0 there, but D is our answer. Okay, next we've got 54. Okay, so for question number 54, we're told Anne is opening a new savings account with an initial deposit of $250. Which combination of a deposit and a withdrawal will result in a 0 balance? on her account. So she's opening a new savings account. She deposits $250. Okay, so that's everything up to here. Which combination of a deposit, which is putting money in, deposit is money in, and a withdrawal, which is money out, will result in a zero balance in her account? Okay, so if she deposits 20, so we're looking at A right now. If she deposits 20 and then subtracts, she withdraws 270, the net result is her subtracting 250. So let me just put that together. That's like a negative 250. Well, she already had 250 in there, and then she did this. It looks like A is our answer, because that will, she already had 250 in the account, and then she deposited 20. That means that she goes to 270, and then if she withdrew 270, that means she goes to 0. Let's just go through the other answers. If she deposited 270 and then withdraws 20, then this would be a net result of adding 250 over time. So it's not B. C deposits 20 and then withdraws it, so she adds 20 and then withdraws 250. The net result there is she is subtracting 230. Well, she has 250 in there to begin with, so it's not C either. D deposits 250 in the first week and withdraws 20 in the second week, so she's adding 250 and then taking away 20. Well, that's going to be a net result of adding 230, which isn't going to reduce this to 0. So A is our answer for 54. Okay, 55. You know, these three people are running in a race: Andy, Brenda, and Carla. In how many different ways can the students finish first, second, and third? Well, we could go on to write a list ABC, and then ACB, and then CAB, and then CBA, and then BAC, and BCA, and that's it. So there's 6 different ways. So we just did this by writing a list. Otherwise, if we can look at this as 3 different places. Now, how many options are there right now for the first place? Well, there's 3 different people who could go there. Then, if one person's already put in first, for the second place, there are 2 different people. And if first and second are filled, for third place, there's then 1 option for. So the fundamental counting principle tells us that if we multiply them all, we get the total number of outcomes, which in this case is 6 as well. So for number 55, D is our answer. Okay, for 56, Will bought 24 juice boxes. So I'm just going to set up juice boxes. You've got 24, and the cost was $7.30. So I'm just writing a ratio, comparison of 2 amounts. Which equation can be solved to find the amount of each juice box? Okay, so this is really an equation problem. So 24, he bought 24 of them. The total cost was $7.30. Now, if you bought 24 of them, the total cost really depends on the price. So let's just say the price of each. Let the price of each juice box equal B. So therefore 24 times the price of each equals this. This equation can be solved to find the amount that each juice box cost. And so let's just try and compare them. Looks like A is the correct answer for 56. Okay, 57 is asking us to find the mean. So the mean, we've got to add all of these up, and then, so that's the sum of them all. and then we're going to divide by the number of them. So the number of them is 1, 2, 3, 4, 5, 6, 7, 8, 10. So that's 10 right there. 1, 2, 3, 4, 5, 6, 7, 8. That's another 10. 1, 2, 3, 4, 5. So that's 25. So I'm going to pause this just to add them all up. Okay, so when I added them all up, I got an answer of 1342. So when I do 1342 divided by 25, I get a mean of 53.68. And so B is our answer. Okay, number 58. We're told that someone is scuba diving while on vacation. Yesterday he swam, so this is the water. He went all the way down to negative 13.74 feet. Today he plans to go 4 times deeper, so times by 4. How far is he planning to dive? So we're not going to subtract 4 from this. He says he's going to go 4 times deeper, so that's negative 13.74 times by 4. And so a negative times a positive is going to be a negative. So really what we need to do is 13.74 multiplied by the 4, which gives us 54.96, and it's negative, and so our answer is A. Okay, 59. For 59, the graph shows the relationship between the number of teams in a 4x100 meter relay. So we've got to be careful here. We're not asked to do 4 times 100. This really is the name of a race. It's a 4x100 meter relay. So four runners, each running 100 meters. Okay, so they're at a track meet, and the number of runners participating in the race. Okay, so the number of runners is on your y-axis right here, and your number of teams is on your x-axis right here. So if there is 1 team, there will be 4 runners. Does that make sense? If there are 0 teams, there will be 0 runners right here at the origin. So just one thing to note, this is a proportional relationship because it shows a straight line going through the origin. Now it's as the question says, what does the point 1, 4 represent? Well, one thing that's coming to my mind is that it looks like 1, r, so it looks like this gives you the unit rate, but the answers that it looks like it's giving us are all real world descriptions. So what does the point 1, 4 represent? Well, I'm saying 1 is the number of teams, so 1 team, and the 4 is the number of runners. Now let's see which is closest. 1 team will be running in the race. Not necessarily. There are 4 runners per team. Yes, there are 4 runners per team. There are 4 teams per runner. That doesn't make sense. How can 1 person be in 4 teams? And the 1 team out of 4 will win the race. We don't know who's going to win the race. Okay, so B is our answer. There are 4 runners per team. That was number 59. Okay, the last question, number 60. A store sells sheet music at a markup of 6%. So markup means a certain percent on top of however much they purchase it for. So it's going to be their profit. If the price paid by the store for sheet music is A, so that's the price they pay, they're calling it letter A, which equation shows the amount that the customer will pay? Well, if they buy it for A and then they're adding 6% on top, the customer is going to pay A plus the 6%. Now, I see that they're using T here, so T is the total amount that the customer is gonna pay. Now, A on its own, if we think of what percent A is, well, A is 100%, and we're trying to add 6%. So really what we're trying to do is find which equation is the same as 106% of A. So 106% can be written as 1.06, and then A goes right next to it. So our answer is T equals 1.06A, so D is our answer. I'm looking here now, D is our answer, but A kind of caught my eye just then. If A had said A plus 0.06A, this would have then also been correct, because A plus 0.06A is the same as, that would have been the same as 1.06A. It didn't have this A, and so it is not the same thing. D is your answer for number 60.